Points of interest. Number corresponds to locality number on the map. Dalvey Beach, 1. The eastern end of Prince Edward Island National Park comprises long stretches of beautiful sandy beaches, backed by dunes in some places, and lagoonal pools and ponds. Low banks of reddish sandstone and siltstone alternate with sandbanks and dunes along the beach. A great variety of ripple marks, as well as swash and rill marks, may be seen on the beaches, and many of the dune surfaces are also rippled. Away to the east, the dunes are quite high. Some reach nearly 50 feet above sea level. Most of the sand is made of fragments of quartz. Patches of black sand are formed where the water or the wind has separated grains of magnetite from the rest. Pebbles of reddish sandy siltstone, with occasional khaki or gray ones, are spread along the beach near outcrops of red bedrock. The low pond areas probably resulted from the building of the beach across the outlets of the ordinary drainage channels. Dalvey House and the main road just east of it are on the margins of one of these lagoonal pools. The small brooks that drain these pools across the beach are engaged in a struggle to keep open their channels, for the wind is constantly blowing sand across them, and the waves are forever smoothing out the shoreline, where they empty to the sea. Stanhope Beach. Beautiful displays of rippled sand extend for miles along the beach. In some places, the banks facing the beaches consist of sand or glacial till. In others, they are made of the red bedrock of Prince Edward Island. Wire matting and nets have been filled with boulders and spread over the face to slow down erosion of the banks where it is too rapid. You may note that the beach here seems a little redder than usual. This is perhaps because the sands, after being eroded from the banks, have not been washed and worn as much by the waves as they have in other places. Pebbles and rare larger fragments of reddish sandy siltstone are common on some parts of the beach, and are mostly strung out in lines parallel to the water's edge. In many of the rippled areas, the pebbles and fragments of shells tend to lie in the troughs of the ripples. Black magnetite is clearly visible on the crests of some ripples, with the ordinary quartz sand making up the rest. You will find the best preserved ripple marks in a wonderful variety of shapes and patterns behind the slight bars that have been built by the waves. Bridge over inlet to Cove Head Bay. When the north shore of Prince Edward Island was drowned by the sea, shallow river valleys were flooded, making estuaries along what is now the park. Cove Head Bay and Brackley Bay are two of these. A map or an aerial photograph clearly shows the outlines of the old valleys, with the brooks still coming into their inland ends. Waves and currents along the shore build up sandy bars across the headlands and across the mouths of the estuaries. They would probably have been completely sealed off long ago if the tidal currents in and out of the estuaries did not keep the openings more or less clear. This bridge is over one inlet that allows the water to circulate in and out of the combined Cove Head Bay and Brackley Bay area. As is common in such places, there is much shifting of sand back and forth, and each storm may produce visible changes in the shape of the shore. Brackley Beach 4. Along the back of Brackley Beach, the dunes become quite high, some reaching 60 feet. Rippled surfaces are common in all the dune areas, and from place to place subtle differences in the size of the sand grains are caused by the selection and sorting of the sand by the wind. Blowouts are common in the grassed areas of the dunes and show how the wind is constantly remodeling the landscape. Brackley Beach displays wave and current ripple marks in great variety. Causeway to Rustico Island 5. Here is another opening in the string of barrier bars and beaches that have been built by the waves across the irregular line of the flooded north shore. It is similar in most respects to the Covehead Harbor Inlet, and it is kept open by the same processes. The building of the causeway has undoubtedly changed the natural shifting of the sands in the tidal currents. Rustico Island 6. This is an island link in the chain of barriers, bars, and beaches that the waves and the shore currents have built across the headlands and inlets of the irregular shore of Prince Edward Island. Some of the sand has been eroded by waves from the shallow bottom offshore and has been carried in to be deposited along the shoreline. Some has been swept along the shore by currents and left for the waves to build it up along the beaches. When some of the sand dried out, the wind picked it up and built dunes out of it. The estuaries back of Rustico Island and the nearby points are perfect examples of flooded river valleys and clearly show the main valleys with their tributaries now filled with seawater. North Rustico 7. The beach at the east end of this section of the park extends from the mouth of Rustico Harbor northwest for about 3/4 of a mile, where it ends against a point of red rock. A walk around the point under the low cliffs will show you an entirely different set of shore conditions from those along the beaches, for here the bedrock meets the sea directly. The profile from the tops of the cliffs to the sea has 3 parts. On the top, the grass and occasional low bushes are rooted in dark, reddish or brown-red soils a few inches deep. These soils have come from partial decay of the material underneath, with the addition of organic matter from vegetation which has grown on them. The soil is succeeded by glacial deposits, an irregular mixture of clay, sand, pebbles, and boulders scraped from the surrounding countryside when it was entirely covered by a great ice cap. This glacial till varies from a few inches to as much as 20 feet thick in this neighborhood. Its boundary with the soil on top is gradational, but its boundary with the bedrock below is usually very sharp. At this locality, the upper part of the bedrock is made of siltstone with some sandstone. Parts of it are cross-bedded, that is, layered in detail at an angle across the main trend of the beds, which are nearly horizontal. Under the siltstone lie heavy, massive, micaceous sandstone beds. As they resist erosion more than the siltstones, they stand out as a flat terrace in some places. Figure 1 shows the top of this sandstone unit with its jointing and layering, and how it breaks off in angular boulders that form much of the actual shoreline. One may note that some of the bedding or layering surfaces of these sedimentary rocks are ripple-marked and carry some trails. Structures exactly the same as those formed on the beaches today. It is intriguing to think that at this spot the whole cycle of geological change is repeating itself. The sandy red rock with its rippled surfaces and its grains of cemented sedimentary materials formed 250 million years ago is being torn away. The sand coming from it is being moved along the beach area and then is being formed into rippled deposits again. No finer example could be found of one of the basic laws for understanding the geological record, that the processes we see around us now are the same processes that affected the surface of the earth all down through time. Orby Head 8. The same red siltstone and sandstone units that we described in some detail at North Rustico form the cliffs along the shore from near North Rustico to the east end of Cavendish Bay. At Orby Head and nearby, the cliffs are 50 to 100 feet high. A little way west of Orby Head, a small brook crosses the beach and wages a constant battle with the waves to keep open its outlet to the sea. When storms increase the power of the waves, they are able to seal off the brook by building up the sandbars across it. In calmer times, the brook fills up the space behind the bar, spills over, and cuts a new outlet, which may or may not be in exactly the same place along the bar as the old one was. Shore just east of Cavendish Beach, 9. The beach at Cavendish ends against the rocks at its eastern end. Just east of this, wave erosion has sculptured the rocks into a variety of shallow caves and overhanging cliffs, and has bored holes right through a small point there. A small cove nearby has a pebbly beach that is unique in Prince Edward Island National Park, in that the pebbles are made of red sandstone, white quartz, and agate, mixed with fragments of white clam shells and blue mussel shells. The rock fragments are all well-rounded, which shows they have been transported in running water for some distance. They may have come from a conglomerate layer in the bedrock nearby, or perhaps from the glacial debris. Figure 15. Modified ripple marks in the foreground were preserved from complete obliteration by the slight ridge of sand just beyond them. Waves have washed over the ridge to produce the marks on the back of the ridge. In one place, the waves have formed a small delta which covers the rippled area. Erosion of the shoreline rocks has produced a stack or remnant just off the end of the point, about half a mile east of the end of Cavendish Beach. The nearby cliffs and the stack itself are shown in Figure 3. Cavendish Beach. 10. The beautiful sands of Cavendish Beach stretch away to the west from the end of the rocks, which are about opposite the end of Route 13 as it comes from the south. Wave-washed beaches give way landward to a wide, neutral zone with irregular dunes rising behind it. The western end of the beach is the end of the bar across the east end of New London Bay. A great array of ripple patterns on the sand, rill marks, swash marks, and wind features is spread out along the beach. Lagoonal ponds, made by the damming of the drainage by the drifting sand, occur at the Cavendish end of the beach. Crossing the dune zone in a low area and entering the sea across the wide beach is a brook that drains the Cavendish area and the lagoonal ponds. The position of its mouth is constantly changing as the waves and currents build up and tear down the slight beach ridges there. In part of its course across the beach, the swiftly flowing water of the brook makes an unusual pattern on its bed, like that shown in Figure 6. Here, on a small scale, the processes of erosion and deposition are so fast that you can actually see the pattern change as you stand and watch. Figure 16. Many stories are written on the surfaces of the dunes. Here, fragments of grass roots blow back and forth and leave unusual patterns. Faint rippling of the sand shows where wind has left its mark. Footprints of tiny creatures weave across the picture among the shadows of the grass. The long spit forming the western end of Cavendish Beach shows many patterns from the air which are not visible from the ground. The backside of the spit is scalloped because during great storms the waves wash through and over it in some places to spew sand into the calm water beyond in fan-shaped deltas. On the seaward side, the aerial observer may see a rhythmic pattern in the shallow, offshore bar. In deeper water farther out, he may see still other bars which are more or less even and parallel to the shore. As you wade out from shore, you may become aware of these ups and downs in the sea bottom, where the water apparently shallows and deepens. These shapes are due to peculiarities of wave motion, the currents they set up, and the way in which this movement affects the bottom sands, a relationship which is not entirely understood.